Welcome to this lesson on buoyancy. Buoyancy is a fundamental concept in fluid mechanics that explains why some objects float while others sink. In this video, we'll explore the science behind floating and sinking and understand the forces that determine whether an object stays on the surface or goes down to the bottom. Buoyancy is the upward force exerted by a fluid on an object immersed in it. When you place an object in water or any other fluid, the fluid pushes up on that object. This upward push is what we call the buoyant force. It's the reason why you feel lighter when you're in a swimming pool and why some objects seem to rise up when placed in water. The key to understanding buoyancy lies in Archimedes' Principle, named after the ancient Greek scientist Archimedes. This principle states that any object immersed in a fluid experiences a buoyant force equal to the weight of the fluid displaced by the object. In simpler terms, when you put an object in water, it pushes some water out of the way. The upward force on the object equals the weight of that pushed-out water. We can calculate the buoyant force using a mathematical formula. The buoyant force, represented as F sub b, equals the density of the fluid, multiplied by the volume of fluid displaced, multiplied by gravitational acceleration. Here, ρ sub fluid represents the density of the fluid, v sub displaced is the volume of fluid that the object pushes aside, and g is the acceleration due to gravity, which is approximately 9.8 meters per second squared on Earth. An object floats when the buoyant force is greater than the weight of the object. When the upward push from the fluid is stronger than the downward pull of gravity, the object rises and floats on the surface. This is why a beach ball floats on water. The buoyant force pushing it up is greater than its weight pulling it down. On the other hand, an object sinks when its weight is greater than the buoyant force. When the downward gravitational pull is stronger than the upward push from the fluid, the object descends to the bottom. This is why a rock sinks in water. Its weight is much greater than the buoyant force acting on it. Density plays a crucial role in determining whether an object floats or sinks. An object floats when its density is less than the density of the fluid. In this case, ρ sub object is less than ρ sub fluid. Conversely, an object sinks when its density is greater than the density of the fluid. So ρ sub object is greater than ρ sub fluid. This is why ice floats on water, because ice is less dense than liquid water, while a metal coin sinks because it's denser than water. Let's look at some real-world examples of buoyancy. Ships float despite being made of steel because their overall density, including the air inside them, is less than water. Hot air balloons rise in air because hot air is less dense than the cooler air around it. Rocks sink in water because they're denser than water. And fish can control their buoyancy using special organs called swim bladders, which allow them to adjust their overall density and stay at different depths in the water.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.